This is Terry, and on this video, we are going to be talking about factoring trinomials. So all a trinomial is, it just means we have three different terms in an equation. So in our equation, we have y squared minus 11y plus 28. So we can see that we have the three different terms in there. So when we're getting ready to factor something, we always look and say, hey, is there anything we can factor out, such as the greatest common factor? So we look at our numbers. They don't all have numbers, so we can't factor a number out. Then we look at our variables. Well, two of them have y's, but the third one doesn't have a y, so we can't factor out any variable. So we have no greatest common factor. So when we look at a trinomial and we want to factor it, the first thing we're going to do is we're going to make two sets of parentheses. And the variable that's got the squared is usually the very first thing in our equation. We're going to put it in each set of parentheses. And we're only going to put one. We don't square it, because what we're thinking is if we multiply those together, they should equal that y squared. So y times y would equal y squared. All right, so the next thing we're going to do is we're going to bring down the number that's by itself over to the side. And we have 28. So we're just going to bring it over and write it down. Okay, and what we're going to do is we're going to factor that 28. In other words, we're going to come up with all the numbers, the pairs of numbers that can multiply together to make 28. So we always start with 1. So 1 times 28 equals 28. And then we go to 2. So can 2 divide into 28 evenly? It sure can. 2 times 14 equals 28. So then we look at 3. Can 3 divide into 28 evenly? Nope, doesn't work. So let's look at 4. Can 4 divide into 28 evenly? Yes, 4 times 7 makes 28. All right, so we know we could go further, 5 and 6, but they don't work. So we know that this is our sets that can multiply together to make 28. Now we're looking at these sets of numbers, and we want to know which set of these can add or subtract to make the number in the middle. We want to make that negative 11. So we want to look at 1 and 28. Can we add those and make 11? No, it makes 29, doesn't it? Can we subtract them and make 11? No, that makes 27. So those don't work. Okay, so let's look at 2 and 14. If we added 2 and 14, we would get 16. That doesn't work. If we subtract them, we get 12. So that doesn't work. So let's look at 4 and 7. Can we add 4 and 7 to get 11? Yes. 4 plus 7 equals 11, right? So those are going to be our numbers. So now we have to figure out how to make those make a negative 11. So we can look at this. Sometimes you can just look at it and you know. Sometimes you might not. So I'm going to write down the different ways it could look, and we'll see which one is correct. So they could both be positive, they could both be negative, or one could be a positive and the other a negative. So if we look at this and we said we had a positive 4 and a positive 7, they make a positive 11. And remember, we need a negative 11. Okay, so negative 4 minus 7, hey, that is a negative 11. So our numbers would be negative 4, negative 7. So we're going to take those numbers. You put one in one set of parentheses, the other in the other set of parentheses. And once you have done that, you have completely factored this trinomial. If you wanted to check yourself, as we've talked about before, you could actually use your FOIL method and you could multiply back. So it's the first term in the first set of parentheses multiplied by everything in the second set. And then remember, it's the second term multiplied by everything in the second set. And if you multiplied that back, you're going to get the original answer that you started with, or the original question that you started with. All right, so let's look at another one here. So it's going to be a little bit more complicated, but we will get this figured out. So we've got 2x squared minus 5x minus 3. So the first thing we do is we always look and say, hey, is there anything that we can factor out? Well, They all have a number, so let's see if we can factor anything out. We have 2, 5, and 3, right? So let's look at those. And we always start with our smallest number. And so we're going to factor it. We have 1 and 2. So now we're going to, that's the only far as it will factor. So we're going to look at the biggest one first, 2. And we say, hey, can 2 divide into 5 evenly? Nope, it doesn't work, does it? Now 1 can, but we don't really worry about 1 because everything can be divided by 1. So these 3, besides 1, they do not have anything in common. So we will not have a greatest common factor. So I'm just going to go ahead and rewrite our original problem just so we can see it a little better here. And so we can't factor anything out. So if you remember, we talked about if we had a trinomial, we're going to first start by making 2 sets of parentheses. And then whatever the variable is, we're going to put him in each one because an x times an x would make an x squared. Okay. All right. So a while ago, we said, hey, just take the number on the end, take it over and write it down, correct? But in this case, it will not work because we have a number right here in front of x squared, and that messes everything up. So now what we're going to do is we're going to take that number and we're going to multiply it by the number at the end. Okay, so what is 2 times 3? Well, we know that is 6. Okay, and so we are going to factor 6 now. So we can say 1 times 6 is 6 and 2 times 3 is 6. All right, so now we are trying to figure out which set of these pairs of numbers, 1 and 6 or 2 and 3, could add or subtract to make a 5, a negative 5 actually. So let's look at this. Can 1 and 6 make a negative 5? Sure, if we said 1 minus 6, that gives us a negative 5, doesn't it? Okay, so let's make sure it's not the only one because sometimes you'll have more than one. So let's look at 2 and 3. Can 2 and 3 make a negative 5? Absolutely. Negative 2 minus 3 equals a negative 5. Ooh, so they both work. So how do we know which ones to put in our sets of parentheses? Well, we also said they have to multiply to make that last number, correct? So our last number here, if you'll notice, our last number has a negative sign in front of it, okay? So it's almost like this is a negative 6 out here. So how can we make a negative 6? So what is 1 times negative 6? That's negative 6, isn't it? But negative 2 times negative 3, that makes a positive 6. So we know this is the only one that actually adds and subtracts to make a negative 5 and multiplies to make that negative 6. So we're going to go ahead and write those in here. We have plus 1 and we have minus 6. So 1 goes in one set of parentheses, 1 in the other. Okay, so we would like to say, woohoo, we're done with that, but we're not quite done yet. So remember, we multiplied to get that 6 to the side, right, by that 2. So we have to get rid of that 2 again. So this time we're going to divide by that 2, and we're going to bring him down and put him under each one of those numbers that we had in our set of parentheses. Okay, so let's see what happens here. Let's see if we can simplify. So we have x plus, what's 1 divided by 2? It just stays 1 over 2, right? And what is negative 6 divided by 2? That is a negative 3. All right, so this answer is correct, but they like it in a little bit more correct form. So what we're going to do is if we're left with a fraction, we're going to take the bottom part of that fraction and we're going to move it back in front of our variable in that set of parentheses. So it's going to look like this. It would be parentheses 2x, because that 2 is going to go back in front, plus 1. So you can see I left the numerator, but the denominator goes back in front of the x, and then the other one just stays the exact same. And now we have completely factored this trinomial.